Okay, it's recording. Welcome to today's class. We'll be going through practical one's memo for computer science 3B. So let's get started. So let me set up my environment. So there's the practical that we'll be going through. This is a previous practical, right? But then it's going to be similar to what you're going to be writing tomorrow. So yeah, let's get started. So I'm going to go to my downloads folder and then I'm going to extract my folder. Okay, I don't think it extracted. Okay, extract. And then it's extracting. There's the folder. And then now I open Visual Studio Code. So we should have everything. The assembler, there's the assembler there. Okay, so what I'm going to do is I'm going to close this folder and then open the new folder that I just extracted. So let me go to open folder, downloads, MESM, select folder, then there we go. And then I go to my source and then I go to the template. So there's the template. Remember, you need to update your information there at the top. So there we go. We have our template, we have our setup, everything is fine. Let's get started. So when it comes to this week's practical, you're being introduced to standard input and standard output and standard input. So standard IO. So you going to use basically you're going to use functions. In our case, we're going to use functions to get the input and output the values. So it's a simple program, very simple application. We need to write something like this, right? We need to sum up this. So let's do that. So let's get started. Where should I start? Okay, before we move on, let's talk a bit about strings, right? So with strings, if you do recall, but then I don't think you can recall. I don't. But then for those who really understand how strings work inside the computer. So the strings, the way they work, right? You're gonna have like sort of it's an array of characters, right? It's like this, it's an array of characters. Each letter is at a is stored at a specific index or specific position. So if I have, for example, this string hello, like this, H would be at index 0, this would be at index E, and then the index 1, I mean, and then this would be at index 2, index 3, and so forth. So we would have an array like this, right? Each letter is stored at a specific index. But then before we continue, there's a problem that the computer might face, and that problem needs to be solved. So when it goes through the array, okay, typically this happens typically with assembly and C because they don't have built-in error handling, right? Or error checking, whatever you want to call it. So it can't check, it can't, it doesn't have that capability to store, to, how do I put it? It can't automatically just conclude, oh, this is the last letter, right? As a human being, you can tell, okay, this is where the string ends because you can see it. For the computer, we have to find a trick or a way to tell it, okay, stop there. This is where the string ends. How do we do that? We just denote that by a literal 0, like this. But then we don't call it, we don't typically call it 0. We just call it null, right? So it's usually represented like this. So that's where we get the term null terminated strings, right? By default, it doesn't matter in which language you're using it. Under the hood, all strings are null terminated. It's just that nowadays we have programming language that hide the underlying implementation details of how strings work, right? You just class and then that's it. You just call functions, it's as simple as that. But then when you're coding in C and assembly, you'd have to really understand what's going on. So the way it works is each character is stored at a specific index or in a specific box. So what happens is when the assembler, in this case, is reading your string, it's gonna start there and then it's gonna be like, oh, H, and then it's gonna keep on reading and reading and reading. So you have to tell it that the moment it's reading, right, and it sees a zero or a null, it means that's what it should stop. You should stop excluding the null. Don't include the null in the output. But then in assembly, we typically gonna write it as zero because it's literally zero. In what is this? In C, right? You have this thing whereby you can to create the constant, the null keyword, right? It's derived from C. So it's actually implemented like this. It's literally this. So when you use null and you say is equals to null, you're just saying it's equals to zero. So in this same case, the strings operate like that. The moment the computer or the assembler sees the zero, it's like, oh, okay, I should stop there, excluding the zero. So since we have that in mind, we know what null terminated strings are. So let's start. So let me see. So the way assembly works, right? We haven't introduced loops and whatnot. That's a bit, yeah, jump statements and stuff. That's a bit advanced at this point. So we're just gonna make it simple. So every single string that I want to display on the terminal, I'm gonna store it into a separate variable. So let's say if I want to ask the user enter Y0, I would store that string on its own. And then to ask the user again to enter Y1, I would have to create another different string and so forth and so forth. So yeah. So let's look at the practical. Write an 8086 assembly program, which is a 32-bit based assembly program that will calculate the average value of a given part of an image applied with the kernel. The formula is as follows. It's a very simple formula. The problem is assembly is it's quite complex. So that's why they try to make the practicals as simple as possible since they're still introducing you. But then when you start getting to functions and loops, yeah, you you expected to know a lot then. So you're allowed to create global variables. There's no local variables yet. We haven't used local variables. We'll use them when you get there. And then string prompts, you see, they wrote it in plural. They said string prompts. Like I said, for Y0, it's going to have its own string, K0, its own string. All of these variables, you're going to create strings for each of them in order to get the input to display to the user so that the user knows what value to enter. So your program must ask must ask the user each of the input values. So from Y0 to Y3 and K0 to K3, and then display the complete result. This is the average. You need to display the complete result. So let's start, right? We want an average. So as you can see, we are dealing with integers here. All of these are D words. And then this is going to be a double, right? But then we don't actually need the double. If you remember, we'll get to the average. The average is actually very simple, straightforward. It might look like it's very tough, but it's very easy. That's something you shouldn't even be worrying about. We'll get to that when we get to that. So for now, let's create the string prompt, right? So to declare a string prompt, right? So let me minimize this. Under the data section where we put our variables, I'm gonna name them, right? I'm gonna say str y should I say Y0 or YO? Let me say Y0. So I'm gonna declare it stry0, which is basically the string that's gonna store the input or the string for displaying to the user that enter Y0. That's why it ends with Y0 there. You could have named it str input y, but then you see the variable becomes very long. We don't want to have very long variables. So why am I using byte? Because remember what I said. Each of these characters or letters within the string, they're actually stored in a specific box or an array. So we need to use the smallest possible data type, right? Of which case it's a byte. So when we use byte, what we're saying, we're telling the computer to allocate a byte each for like the maximum is a byte for each of the letters or characters that are going to be that for each of these boxes. Let's just say for each of these boxes, they're going to be a size of 1 byte each, even for the terminal for the zero for terminating the string. They'll all be byte. And is remember a byte is just equal to 8 bits or binary digits. So basically the number that you can represent in terms of an integer is 2 to the power of the number of bits, right, which is 8 minus 1, which is going to be 7, right, minus 1. So this should be, I think, 256, if I'm not mistaken. Let me quickly calculate here, but I think it's 256. Yeah, okay, if it depends on how you're using you can use the negative values, and also you can use both negative values and positive values. So when you use both, it's actually the maximum is going to be 127. But I think in this case, since we're going to need to use both negative and positive, it's just going to be 127. Yeah, it's 127. So I'm getting the 256, if you remember your data types, for those who are paying attention with data types, you've been doing this thing since first year in Java everywhere. Even last semester, you're doing it, data types. 127 is a very common number. If it's 127 if it's unsigned. Unsigned meaning it's from the negative to the positive. So if it's signed, I mean, it's going to be from negative to the positive domain. So in this case, it's going to be minus 127 to 127. So this is the range of the values that the byte can represent, right? Which is going to be sufficient for ASCII. Remember, for this practical, we're using ASCII in an ASCII table, right? So ASCII table, which is basically a mapping of basically each integer represents a specific character in a computer. As you see the 0 that I was talking about, it represents null. So we're going to use that 0 to tell, okay, it's null terminated. It means that it ends with a null. Remember, each string is null terminated. So let's write the string. So it's normal. The way you write it is the way you normally write it. So I'd say enter value of y0, right? And then I'm gonna put the colon there, space, and then I'm gonna put a comma, and then I put a 0. So when I use byte, right? What's gonna happen is that it's gonna allocate the byte. E is gonna be stored in a box of a size. The size is gonna be a byte, even n. Each of these letters, even this space, it's gonna be allocated. We're gonna allocate a byte for it. Even this 0, we're gonna allocate a byte for it, so that when the assembler is reading, it's gonna read E N T E R and keep on reading, and then when it sees the zeros, it's like, oh, that's my cue. I need to stop. But then when it stops, remember, it's gonna exclude the 0. The 0 just helps tells the assembler where to stop. So we have the string for y0, right? So so I have to repeat this a couple of times. It's from y0 to y3, and then k0 to k3. So let's do that. So str y1 byte enter value of y1, and then str y2 byte enter value of y2. And then remember it's null terminated. And then the last one, y3 byte data type, right? Enter value of y3. And then we have for y, right? This is from y0 to y3. And then we need to also have k0 to k3. So str k0 byte enter value of k0. So I'm going to put a colon and then a space and then 0 to terminate the string. And then strk1 byte enter value of k1, 0, and then strk2 byte enter value of k2. And then strk3, which is the last one, byte enter value of k3. Okay, so we have all of these things, but then we also need to display we have the strings to output when we're getting all these inputs, these values, right? We also need to have a string that displays what the average is. So I need to also create that. So I'm gonna say string not prompt, string output for average, right? Basically the string that will be displayed when I'm displaying the output or the average, right? So str average, that's what I'm gonna name it so that I remember. Or I can say str av, right? Byte enter value. Okay, no, the average is, right, and then I put that, and then I terminate it with the null so that the computer knows this is where the string ends. And then there's few things that we're gonna need. Okay, I think there's only one extra thing, a new line character. If you remember in C++, right, we have end line to move the cursor from the current line to the next line, or the forward slash. It's typically called the line feed, right? So how do we denote a line feed in assembly? Like I said, ASCII is very important. The same way we use the 0 to denote a null, so that the computer knows this is a null terminated string. I also need to find the line feed. There it is, line feed or a new line. If you remember end line or a new line, you use the integer value 10. That's the ASCII equivalent for that code, for that character, right? So I'm gonna say str new line so that I know what I'm outputting. So the new line I'm gonna say 10, right? Remember this new line is still a character. So it's still basically still a string in a way. So I need to terminate it to tell it when to stop. So I need to put the 0 there. It's null. Remember, strings are now terminated. So we have all of these variables, right, for outputting the string prompts when we're asking the user for input. Now we need to declare the variables from y0 to y1, all of the variables. Technically we don't need to declare all of them if I'm being frank with you. We don't need all of them. But then for the sake of getting used to programming in assembly, I would take the more mundane approach. I would declare each of the variables. So I would declare y0, y1, y2, y3, up until k3. And remember, all of them are integers, right? So I'm just gonna say, okay, I'm just gonna say variables. I don't know what to call them. So it's gonna be int y0, right? And then remember, it's integer, so I'll use d word. And usually by default, just know it's gonna initialize it to 0, right? So you can use the question mark. So in this program, we're gonna use question marks to say that it doesn't have a value yet. But then automatically it's gonna initialize it with the value of 0. So I'm gonna have int y1 b word question mark, int y2 d word question mark, int y3 d word question mark. And then we go to the keys now. Int k0 d word question mark, int k1 d word question mark, int k2 d word question mark, and then the last one int k3 d word question mark. Right? So we have our variables, we are good to go. As for the average, as for the average, I won't need a variable for it. Why do I say so? Remember our registers. This 108 will be stored inside the EAX register. The remainder will be stored inside the EDX register. So you see, I actually don't need a, I don't need a, what is this? I don't need a, what is this? I don't need a double data type, right? So that's why I don't introduce it yet here because it's not needed. Because if you remember what we talked about in the previous video, if you did watch it, if you didn't, well, that's your own funeral. So EAX, this is the accumulator, and then EDX, this is where we're usually gonna see the remainder. That's where the remainder goes, basically when you divide. Just keep that in mind. So what do I mean by remainder? Let me show you what I mean. So if I say 1/3, right? This is going to be 0.33 recurring, right? So let's just leave it to 3 decimal places. So when you divide, right, what's going to happen is in the EAX register, it's going to store the front portion of the number. Whether it's this big number, it's going to be stored inside EAX. So let me use an actual number so that it's easy to see. So let me not do that. Let me just say 725, right? So what's going to happen is 725 will be stored inside EAX, and then there's 3 digits to be stored inside EDX register. So this dot, it's a string. It's just a character, right? It's a char. That's something that we have to output. So to output, basically, if you remember the previous video, if you did watch, remember when I said basically the output for a double, you'd say the value inside EAX register, you output a dot, and then output the value inside EDX, which is basically going to give you 725.333, and then you're done. So with that being said, we need to also declare this dot, right? It's up to you. You can use the numerical value by looking at the ASCII table. You can. So let's look at the ASCII table. There's the dot. So I'll set it to 46, right? I'm just going to show you that there's many ways you can go about it. So str dot, I'm going to literally call it a dot. So the integer value is 46. So this would be a dot in ASCII table, right? You can also do this. Trust me, it doesn't really matter how you go about doing it. You can also do that. I'm just choosing the 46 to show you that it's possible. So we have this, right? So I'm gonna leave those comments there so that you just look at them. So let's see, what do we need? So let's introduce the functions, right? We have functions that we use to get the input from the standard input stream and standard output stream. So if you look at your io.inc, it's like a library, right? Just think of it in that sense. So we have all of these strings, right? We have output str, which outputs a string. We have output int, which outputs an integer. We have output float, which outputs a float. Outputs a float that is, I think that this one is a float 8, I'm not sure, but then I think it's like the 32-bit version of the float. And then this is input int to get input to get the input from the standard input stream, which is an integer, and then input str to get a string from the standard input stream. And then warning, duplicate, include file. Okay, so this is just code. So if you remember in C++, you usually did hash include, right? So we're gonna do the same thing here. So I'm gonna do it it can be anywhere. I'm just gonna do it here. I'm just gonna say include. It's not, let me just, I wouldn't say it's actually a header file, but just view it in terms of a header file. So I'm gonna put the header file like this, the header inside quotation marks. So how do you include? It's simple. You use this keyword include, but then it's in all caps. So include like this. What's the name of the library that you want to include? It's io.inc. And then we are pretty much done with including. So now we can use the methods. So to output, right? To send output to standard output, right? Or to the terminal. Standard output is in this case we just represent the terminal. So how do we send output to the terminal? Using those functions. So let's say you want to output a string. To output a string, you do it this. Output a string, you do it like this. You call the output function output str, and then comma. Remember the comma, after the comma, you put in the parameter that you're going to pass. What does it take in? It takes in, you have to always put ADDR, which is the address of where the string is located. And then what's the name of the string? So here is going to be the name of variable. That's how you use it. And then to output an integer, it's simple, straightforward. You just say output int, and then you can either use EAX, a register basically, or and even I think even an immediate value, right, which is a literal, or you can output for a memory location, which is basically the name of a variable. So this is how you would output, and then input is straightforward. So for now, we're just going to focus on getting input from getting integers, not strings. So input, there's the input. You call the function input int, right? You don't pass in anything here. You just write one line and say input int. But then to actually the full code, right, is in front of it. You have to say invoke. Invoke means call that function. So I just forgot to add there. So you need to say invoke. So let me minimize this. So there's the full usage of the functions, right? You invoke or call the method, and then you pass the parameter after the com. That's the parameter that you're gonna pass. If there's more, you can add more commas. But in this case, we're gonna have one parameter. So since you have a rough idea of what's going on, so let's do that. So what do you want to do? We want to output these values, right, from str0 to stry0 up into strk3, which is going to be a lot of code. So let's do that. So what I'm going to do is I'm going to say prompt the user for inputs, right? Simple. So what do? I invoke my function output str, and then it takes in the address of that variable, right? What's the variable? We're going to start with stry0, right? And then for now, let's just output so that we see if it's indeed working. Let's try to run it, right? Come on, so /create .bat template. There we go. So as you can see, I hope you can see what I'm seeing. Yeah, so as you can see, there's the string. It was displayed. But then we did, like I said, we needed that end of line character. See, we didn't put an end of line character. That's why this string is on the same line. But then if you get input automatically, it's gonna add the end of line character. So we have the output to know that it's indeed working. So the formula is remember, you need to do things in order. After outputting, right, the only plausible thing to do is to get the value. Because if you output this and then in the next line you output the next string, that string is already up there and you haven't gotten the input. If you get what I'm saying, this is what I mean. I mean, usually when you get input, right, you say enter, let's say age, and then the cursor waits there, right? And then you get input, you type, let's say 78, and then you press enter, and then you get the next input. So that's why I'm saying you need to do it in the correct order. So the first thing the output is this. After outputting the string, we get the value. So I need to invoke the function for getting the value. So let's do that. So invoke, okay, let me see. So invoke input int, right? We get the value of y0, right? That's what we're doing in that line. So let's test it out. It's good to test out things. So I'm gonna press the up arrow. As you can see, it's the cursor is now showing there. It's waiting for me to enter input. So if I enter 78 and press enter, there we go. You saw what I told you, that if you enter input, automatically it adds a new line character. So we don't have to worry about adding the new line character for now. We're only gonna worry about adding it at the end when we have when we have to display the average. So we have this, we have the strings, and yeah. So basically we need to repeat these two things to get all the single values, every single value. So how many values am I going to get? It's 8. So 2 times 8, that's 16 lines of code just for getting input. So let's type that. So invoke output str, take the address of str y1, and then invoke input int. We get the value of y1, right? And then invoke output str y2, and then invoke input int, and then I don't know, let me see, get the value of y2. I don't know why I don't know. Hopefully, guys, the last week's practical, it didn't take you a long time to write the solution, because you didn't remember, you didn't have to output this. If you're paying attention to my videos, you'd remember that EDX stores the remainder, which is the number after the dot, which is this number. So you didn't have to show it. They were going to see it on their own. So if you spend time trying to output this, that was a waste of time. Because I'm sure even the slides, there's no slides that talk about that. Yeah, there isn't. So you wasted a lot of unnecessary time there. That's why I always say you must watch full videos and understand what I'm trying to say in the video. Don't just jump to conclusions, because you're gonna end up staying in that practical session the whole day, of which you already have the solution, but you're unaware that you already have the full solution. Get the value of y3, and then the thing is, I don't want to copy and paste, because copying and pasting tends to cause problems. But in this case, let me do it since I know what I'm doing. If you don't know what you're doing, don't try this at home. So this will be K0, and then this will be K1. If you forget to change the right places, you can have a lot of issues. And then this would be K2, K2, and then the last one is K3. I just need to put a K there. So yeah. So what happens when you invoke this input function? So what happens when you invoke input int, right? So when you invoke input int function, input int or input str function, when you invoke those two, right? What happens is, okay, let's not get to input str because I don't remember us using it in assembly. It's there, but then I don't remember using that function, ever using it. So we're just gonna focus on input int only. So if you when you use input when you invoke the input int function, right? What happens is, remember, invoke it just means to call the function. So when you invoke or call the input int function, what happens is the value is stored in EAX register, which is the very first register at the top. So this one I'm gonna call it practical one notes. They will be included in the video description. So let me see. Okay, so okay, this is the right folder. So the value is going to be stored inside EAX register. But then remember, we have variables. So we need to move it from every time so remember, everything needs to be done in order. Immediately after calling input int, the value is now stored inside EAX register. So we need to retrieve it and store it into a variable. So we're gonna do that. So all of these variables now, they need to come to use. So there's gonna be a lot of move keywords here. So I'm going to move into, remember, this is the source, and then no, this is not, this is the destination, right? And then this is the source. Source means where it's coming from. Destination means where you are, where it's going. So I'm gonna store it inside Y0, and it's coming from EAX register, right? So move from, which is the source, EAX register, into the variable Y0. And then I'm gonna copy this and then put it there again. And then, okay, this is still Y1. I'm gonna repeat that. Remember, everything needs to be done in order. In this specific order, I output the string here. I get the input, and then the value is now stored inside EAX register. So therefore, I move it from EAX register to my variable. So that's why that's why I know exactly where to place the line of code, because I understand the logical flow of it. And then this is going to be K1. And then this is going to be K2. And then the last one is K3. Right, so there we go. We have this, so we're sorted, right? So so far we can assume the values are stored, right? But then let's just test it out to be sure. I, for one, think the values are going to be stored. So let me say 7, 9, 8, 2, 12, 90, 200, 78. There we go. No issues. The program didn't crash. So we know we're on the right track. So we have our solution here. So far, that's what we have. So basically we're able to get the input. Now what's left is to calculate. So what is it? What is it that we that we're calculating exactly. So we're calculating average value of a given part of an image applied with the kernel. So I'm gonna add that comment there to just say that's what we're going to calculate now. So basically we're calculating the average. So we have that. Okay, so let's calculate the average, right? So how do we calculate the average? Remember, we just have to use the registers. So what I'm going to do is I'm going to copy this, put it here as a comment. So this is what we're trying to achieve, right? So remember that we we how do I put it? We EAX stores the quotient, right? Which is the value in front of the decimal, excuse me, and then EDX stores the remainder. So we can use EBX register to store the other value that we're going to divide by. So what I'm going to do now when it comes to calculating, so let me see. There's many ways you can go about doing it. You can also use ECX register. But the simplest way that I'm going to go about doing it, right, is this. Let me show you what I have in mind. I'm going to move into EAX register, right, one of the values, and then move the other value into EBX. And then I'm going to multiply, right? And then the answer that I get, I'm going to store it in a variable, right? In some variable, let's call it int product, right? I'm gonna move the value inside int product, right? And then I repeat those same steps, I reuse the same registers. Because remember, every time you move a value into a register, it deletes the value that's already there. So if I do not I don't keep track of the current value that I have, the current product that I have, then it's going to be a problem for me to actually find the value. So let's think about the second round now. When you have the second set of values, remember we start with y0 and k0, and then we need to multiply them. And then the second phase is to multiply these two, but then add them to the current product. So that's the logic is that we're going to, the second step when you multiplying the other two numbers, we're going to multiply them, get the answer. Remember the answer is going to be stored back inside EAX register, right? Then I'm going to add this product to the current product, the current product that we have into the EAX, add it to the number that's currently inside EAX, and then move it back to this variable. I keep on doing that back and forth, because I feel like that's the easiest way for me to go about doing it. There's actually other ways of going about doing it. You can also use ECX register. You are totally allowed. You can do that. But then I'm just going to use a variable to keep things simple for myself. So let's create a variable here to keep track of the product. So int product d word, right? So obviously it's going to start as an empty value. So that's why I'm going to put a question mark there. So empty value, and then that empty value, I'm going to keep on updating it. So the first time, I'm just going to move the value inside that variable. Then the second part, when I'm multiplying, I'm going to add to the current value inside product or int product. So let's do that. So in order for me to multiply these two values, y0 and k0, I can move either of them inside any register. So I'm just going to choose y0 to move y0 inside EAX. So y0 going to be int y0. So, okay, Y0. So I've moved into Y0 into EAX register. Then now I need to move int K0 into EBX register. And then now I need to multiply the whatever's inside EAX register with another value of which where am I getting the value? Remember, I've moved K0, that's the value I want to multiply by. I've moved it to EBX register. So I'm going to multiply the EAX register the the EBX register. How do I do that? We use the mul keyword to multiply by EBX. So you only provide, when you're multiplying, right? You only provide the value, the register or the variable that you're multiplying by. It's good automatically. It defaults its default location its default location is going to be the EAX register. So when you have this line of code, it's going to go by default to the EAX register. Look at what's currently inside EAX, multiplied by what's currently inside EBX register, and store the value back into EAX. So right now, after executing this line 84, I have the value of EAX, the product of these two values. It's now stored inside EAX. So I have to move it to my int product variable. Move product of y into variable, right? So I'm gonna move the product into product, and I'm getting it from the EAX register. So there we go. I've moved the product. So I've stored the product. So this product over here is currently stored. So now we continue, we repeat the same thing. We have to multiply this. So let's do that. So I'm going to say move EAX. Into EAX, I need to move into Y1, right? And then into EBX, I need to move into K1, right? And then I multiply by the value inside EBX. Remember mul, right? It multiplies unsigned numbers or positive numbers only. You could use imul, doesn't make a difference. But then if you look at these values, is there negative value? Nope. So I'm gonna use mul, the mnemonic mul, or this abbreviation mul. And then now this is a trickier, this is a tricky situation. So let me also add comments so that you guys can know what's going on. So here I'm multiplying this. That's what I'm calculating there. And then here I'm calculating that, right? And then now the tricky part is I have the next value, which is the product of these two values, right? I can't just simply move it into this variable because if I move into it, it's going to delete the current product, which is this one. So therefore, what I need to do is to add to this current product. How do I do that? So what I'm going to do is I'm going to say add to the current product. Assembly is a bit tricky. You have to go back and forth the registers. So let's pay attention. What are we, where are we currently? Where's the value now currently of this product? Remember what I said, if you use the animal, you multiply or you divide or you add. Okay, multiply and divide. Let's just say multiply and divide. The add is a bit different. It goes by it defaults by default it goes to the EAX register and and updates that value inside the EAX register, and then the answer gets stored back into the EAX register. So after this line of code, EAX has the product. This product, it has that value. So all I have to do is add to that product inside EAX register. So I have to say add int product. There we go. So before we continue, let me try to run it. Okay, no issues. It's compiling. We are following the rules for assembly. So now after adding, EAX register has the sum. So basically EAX register has this. That's what I'm calculating here. That's what we're calculating there. So we have the sum, it's now stored inside EAX. But then in order for me to proceed, remember every time you move a value into a register, it deletes that value. So that I don't lose this value, I need to reuse this variable because whatever value was inside this variable, it's no longer productive, right? No pun intended. It's no longer productive. We don't need it anymore. So I'm going to move the sum now from EAX back to the variable in product. So move the sum of, right, back into int product variable, right? So we've moved the sum back into that in product variable. So we have track of it now. It's reserved or it's stored. So now we have the last step of which you kind of get the idea now. So we're just gonna repeat this, but then I'm gonna do it separately. So we need to calculate this. So calculate that. So move into E. I want to move into EAX. What value? Int y3. No, what am I? What's going on? It's not. It's quite long. I'm skipping. We still have y2 and k2. So yeah, it's gonna be quite. Yeah, this code is gonna be a lot. You see, so it's already at 105, and we're not done, or we're not even close to being done. So we're actually doing y2 and k2. Yeah, we're doing y2 and k2. So I'm gonna move into EBX. What value? Int k2, because we're trying to multiply y2 and k2. And then multiply by EBX. Yeah, so here, remember, this is just multiplies EX register by value in EBX register. So multiply it by that value. So now EAX register has this product, and we still have that sum right inside. I chose in product because, yeah, I could have said in sum to make it simpler. So let me just say in sum, because if I feel like in product sort of like doesn't clearly explain what's going on. So I'm gonna change this to int sum, int sum. There we go. So remember, after multiplying, the product is stored back into EAX register. So we take the current sum, we add it to the current product that's stored in EAX register. So I'm going to say add to my EAX register what value? Int sum. So basically, this is just saying EAX plus int sum, and then storing it back inside EAX. So this in essence, that's what I'm doing there. It stores it back into the EAX register. So now I need to move that value because I'm gonna use the EAX register to continue and multiply, right? So therefore I need to move that value back into the variable in sum because we've already used the variable inside in sum. So what this means, I'm just doing this. So it means move this value inside EAX, move it into in sum. So we're almost done. We are left with the final calculation. Not really final, but yeah, in terms of summing up, we'll get the division. So it's K3, Y3, K3, right? So let's move values now. So move into AX register, int Y3, and then move into EBX register, int K3, right? And then as always, multiply by EBX. So basically what this multiply, basically this means this EAX, and then is equals to the current value inside EAX multiplied by the current value inside EBX. So that's, in essence, that's what that line means. So we have that, and then we have the current product, right, inside EAX register, as you can see by this line, by this comment. So we need to add it back, add the sum, the current sum that we have into EAX. So I'm going to say add EAX, add in sum. which is just going to be EAX is equals to EAX plus int sum, right? And then now I move the current value, the sum inside into int sum. Let me see if I need to do that. Okay, at that point I don't, because all I'm left with just dividing by 4. Yeah, so at this point I don't have to. You see this line of code, I don't have to now. Because if I do the sum, this line of code, right, I would have to move it back in sum back to EAX, then multiply. You see, it's not necessary. So I just leave it as it is. So I have the actual total, the overall total. So let me create a variable for my divisor, which is 4, right? So I'm gonna call it int divisor, b word, which is 4. The 4 is gonna be the value that I use to divide, right? Because that's the requirement for this question. You see, I need to divide it by 4. So let's divide the EAX register by 4. Divide it by 4. What's divide the sum inside EAX register by 4. So let's divide that. So it's going to be div, since I'm dealing with positive numbers. You could also just say idiv, but then that one it should work the same. I think it should work exactly the same. Yeah, should work exactly the same. But then I prefer to use the right mnemonic or the right command based on my data type. I'm only dealing with positive numbers, so I'm gonna use div. So divide the EX register by 4. Which variable store is the value for? It's int divisor, that's the variable. So I'm gonna use that one. So after dividing, right, what happens is EAX is gonna store the quotient, right? And then EDX is gonna store the remainder. We discussed this. So now my goal is, so let's just calculate it, right? Let's just run the program and calculate, right? Let me look at my data, example data, testing data, right? We have 76, 76, 153. There we go. And then, okay, I don't think I'll need this. And then 25, and then 229. Right? Okay, we are not done. And then 1220. 1220. So it didn't crash, no error. So our code is fine. For now, we're not sure of the answers yet. So we're going to output the answer. So we have the average, right? It's inside EAX register. So since we have the average inside EAX register, actually that variable that we have int we didn't create the variable for int average. Yeah, we don't need it, because I was about to say if we created it, we don't need it, since EAX has the quotient and EDX has the remainder. So let's output the average. So output the average. So how do we do that? Remember your functions. So invoke output str, the address of str average, right? Which is the string for saying the average is, that's that string. And then after outputting that string, I need to output the quotient, right? So I need to output the quotient, right? So I need to output the quotient followed by a dot, followed by the remainder, which is EDX. So that's what I need to output. So output this, right? So let's output that. So let's start with the value inside EAX register, right? So I'm gonna say invoke, it's an integer, right? So invoke output int, what integer I'm trying to output is the one inside my EAX register. And then I also need to output a dot now. Output dot, this dot here, right? So let's output the dot. So invoke, which is a string, so invoke output str, add, which is the address, and then str new line. Oh no, not new line, str dot, right? And then since we've outputted the dot, now we can output edx. So output edx value or the remainder value, right? So invoke output int edx. And then we could also just output an end of line character to make sure that our code is readable. Output new line character, right? So invoke output str new line. So hopefully this works. So let's test it out. So I'm going to expand this and then I'm going to run my project. So we have y0. Let's start with the first data, right? 76, 153, if I'm not mistaken, 53, 25, 229, 229, and then 1, 2, 2, 0, right? Yeah, 2, 2, 0. Okay, so the average that we're getting now, we're getting an output of 16, right? Let's see. So we are far from what we actually expecting as output. So I think let me see, I think the main issue could be, yeah, the main issue is here. You see here, in terms of summing up. So let me see, it's y0 times k0, right? Plus y1 times k1 plus y2 times k2 plus y3 times k3. So we have our average here, but at least we know that it's working. So let's try to decipher and see what's the error. Let's see. Let's go back to the beginning, right? To make sure we're getting the right inputs, let's double check. So we output the string to say enter the value of y0, and then we invoke input in to get the input, we store it. Perfect. And then we have str1, y1, str y2, perfect, stry3 int y3, strk0, strk1, strk2 int k2, strk3 int k3. Everything is good so far, so we can assume that the issue is here when it comes to summing up. So let's double check. So the formula states that it's y0 times k0, right? So basically this means that I'm going to say move y0 into EAX and then move k0 into EBX and then multiply the EAX register by the value inside EBX, right? Pretty straightforward. And then I move the product that's currently inside EAX because it's going to be stored back into EAX. I move it into the variable int sum. Then I calculate y1 and k1. Let me just double check. y0, k0. That's good. y1, k1. Right? That's good. So I move k1 and then I multiply the EAX register by that value. But I don't think, let me see. I don't think I should be using to be honest, I don't see a need for using EBX register. I honestly don't see it. Yeah, I don't see the need to use EBX register because technically I could do this, right? I could say int k1, right? So yeah, I don't see the need for doing that. Yeah, there's actually no need for storing k1 using EBX. So let's delete EBX. So let's do that. I just want my code to be as small as possible, right? So int k0 there, because remember this command, you can use a register or a memory location, right? Which is a variable. So this is as short as it can be. And then I don't need this. So this will be int k2, right? And then same thing applies here. I don't need this. This is going to be int k3. Then, yeah, that's pretty much it. So we can output strf, that string that the average is, and then output the average. Wait. Hmm. I think I kind of get what's going on here. So yeah, the EAX, you see, that's the problem with the EAX register. It gets used a lot. So when you're invoking functions like this, you are using EAX register and all those. So it might change, the value might get lost. I think that's the real issue here. That's what's going on here. So what I'm going to do is before invoking all these methods here, the int sum variable, right, is going to store it's going to store the quotient, which is the value in front, right? So let me move into EAX, not into EAX, into int sum, the value of EAX register, right? Because you see, I'm using it here and I'm invoking methods and things like that. EAX register is a very dangerous register to use, especially when you're doing calculations, because you might lose the value along the way and you won't know why. So we have that inside int sum. So before outputting the value of EAX, I need to actually output int sum. I'm not sure if it can allow you to output a variable. Let's see. Oh, it needs registers only. Okay, yeah. So it works with variables. So I'll just output the value inside the variable in sum, which is the value in front, right? Which is the quotient. And then EDX, which is the remainder. So it should be fine. I guess the main issue was just this line, because EAX, we call the function here, right? And then it ended up using the EAX register, right? So let's do that. Provided that my calculation is perfect, but I think it is perfect. That's why I'm getting to that conclusion that it has to be linked to, wait, 229, right? No, 25. Y2 is 25, Y3 is 229. 229 is Y3. And then I'll have 1, 2, 2, 0. Yeah, exactly what I was talking about. You see that our code was actually fine, but then when you invoke methods, that's the thing about assembly. Just remember that when you invoke a method, right? When you invoke a method, what happens is it also uses the EAX register. That's why I said you should be very careful with understanding registers. That's why this line of code is very important. I move or I store the value inside EAX before I call these methods, because it's going to use the EAX register and then I'm going to lose the value. Isn't this the output that you expect? It is. It might not be to test two decimal places, because there's no need to store as two zeros. One zeros will be enough. So let's test all of them just to be 100% sure. So I will clear this, and then now it's just the testing phase, right? So let's test our app. It's pretty much similar. Y0 to Y3 is the same. So 76, 153, 25, 229. If my memory is correct, so you say 25, yeah, it's correct. 3132. So 3132. 3132. 2. There we go. Okay, something. Okay, yeah, the decimal place, that's something we're left with. So as you can see, we still have the right approach, right? So it's 228, the dot, and the 2, right? So the 2, let me see. Yeah. So the 2, so it's actually going to be very complicated. Now we're going to have to add extra things. So the 2, right? Do you know how it's getting the 2? If you take, remember 0.5, right? Just ignore this, the quotient. Look at the remainder. If you take so that means this is not always the case. You see this, the way I was assuming it's not always necessarily the case. It doesn't store it exactly like that. It's sort of like looks, it's very intelligent. It sort of like looks at the device. So look at 0.5, right? You may ignore the 228. The 228, ignore it, right? It's 228.50, which is basically is 0.5, right? Which is half. So 0.5 times the divisor. What value are we dividing by? 4. That should give you a 2, right? That gives you a 2. So we have this value, right? We have this value. So the value that we're actually trying to get, right, is this 0.5, or basically the 5 itself, right? How would we get that value? So basically, you can imagine we have this, right? So this is basically solve for x. Imagine we have x times 4. We have 2 because that's the output, that's what it's storing inside the EDX register. So how do we get x? It's just 2 divided by 4. So basically, I'm going to say x is equals to 2 divided by 4, which gives me what? 0.5, right? Which gives you 0.5. So after dividing here, remember EDX, yeah, hopefully now EDX will now have the correct value, hopefully. So obvious EAX will have the 0, and then we expect EDX now to actually have the 5, right? Or 50 in this case, but then it's going to be 5. So we expect it to have that, right? After converting the 2 in terms of with respect to the device. So let's try that, right? Our 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 calculations are fine. Only even the remainder itself is fine. It's just that it's not calculated or phrased in the right way. So we need to take that remainder inside EDX. So basically, this is what you're trying to solve, right? I'm trying to say take the value inside EDX divided by the divisor, and then you should find the actual remainder. So let's try that. So before we call these methods for outputting the answers, right? Before we do that, let's work with, let's try to convert this value. What's going on? Okay, so we have moved into InSum, we have that value, right? We don't have to worry about that. We have the value stored. So that means that we can safely use the register. So here I'm gonna just write convert the remainder to the correct format. I'm just gonna phrase it in that way. So I'm gonna say move into EAX. What am I moving? My divisor, right? Not the divisor, the value inside EDX, the remainder, which is that 2, right? Because remember, div, it divides the EBA, the EAX register. It divides the EAX register. So the dividend, right? The value that I want to divide or the numerator, I have to move it inside EAX because the div command, it only divides the EAX register by that denominator that I'm gonna pass. So we have this, so I can just say divide by int divisor, right? And then this should, in essence, just say EAX divided by divisor or int divisor, and then store the value back in the remainder is going to be stored inside EDX. That's what I'm expecting. If it doesn't work, then let me see. Yeah, if you divide EDX has to have the value. So hopefully that should be fine. Hopefully that should be fine. So let's test it out again. That's why you always need to test out all the different cases so that you 100% sure that you're writing the right thing. So it's 76, 153, 25, 229, 3, 1, 3, 2, right? Yeah, 3, 1, 3, 2. Mm, interesting. It's still, wait, did I even divide? Oh yeah, I did divide. So I divided the EAX register by the divisor, which still gave me 2. How is it giving me 2? That's what I'm trying to understand. It shouldn't still be giving me 2 because at this point, EDX register should be updated, right? So let me see, 2 divided by 4. That gives me 0.5. If I say 0.5, 0.5, yeah, 0.5, when you times it by 4 and you want to go back, like 0.5, right? Okay, it's a bit tricky now. But then usually this digit, they're not that strict. But then let's see if we can find a way to fix it. So let's test another example. Let's test 2.5. Let's see if we have a similar case or a similar problem. So 101, 178, 101, 178, 116, 35, 116, 35, and then 1 to 4. 1, 2, 3, 4. 1. Yeah, so we have a similar problem here. So the 1 is basically, how would you get that 1? You'd get it by that 20, that 1, right? It's basic. What is 20 for 0.25? It's basically 1 over, it's basically 1 over 2 over 4 is going to be a quarter, right? Which is 0.25. Okay, so let's investigate, right? Yeah, let me do this. So we have this, right? So let me do this, create this program, and then open it inside my debug. So let me open my debugger, not assembler, x64. Okay, there we go. So file, then open, then go to downloads, bin template.exe. Right, so let me see. Mm, okay, let me test something. and then step into, right? And then it's gonna call template.output str, right? And then it should call input int. Let me see. Okay, it's kind of hard to decipher it from that side. Oh, okay, it's running by the terminal. So let me try testing it and see if the debugger will, because I want to see. This I think they should help us see. So 101. So let me do this. So one. So it's just a small problem that we have. 101. Okay, let me see. Okay, so basically there's move. So you see, it's 101, right? Just move the value that I just entered now. So the moment that I get to, you see, it pushes that to the stack, right? And it's gonna use EAX register. And then we have this output str. Let's get to that. Yeah, so you see, there's the string, right? So the string should appear. You see, after I've ran that line, after I've clicked here, you should output the string. So there's the string. And then I should type in a value, and then yeah, it's a bit slower this way, but then just be patient with me. So 178, one. Okay, so it wants me to call the input int function in order to allow me to type, I guess. Okay, it doesn't. This thing is very strict. So let's go back here. 101, 178, 116, 1, come on, 116, 35, and then 124. 35, 1, 2, 3, 4. So as you can see, we have our average there. The only problem is the remainder, the EDX. So what could be the issue with EDX? Because we only use EDX once when we calculate the average. We don't use it every time. So there shouldn't be any extra information or any extra things inside EDX, right? Because I even made sure here that if I happen to find so let me see. If the, okay, let's say if the remainder is 1, right? So 1 divided by 4. Am I getting the right one? Okay, okay, the answer was the same. It hasn't changed because it was outputting 1 and it's still outputting 1. So we expect it to output 2, 5. But then let me just comment these two lines. Then let's run it again. Okay, so 116, no, 101, 178, 116, 85, 1, 2, 3, 4. Yeah, it was outputting 1. It's a very small issue. I forgot. How did I fix it? Remove the device or remove the divide, right? Okay, before we get I want to check something before we get to this part, right? I want to output immediately after dividing. I want to output the value of EDX. So move, not move, invoke output int EDX, right? And then I also want to output a new line character so that my values are not all over the place. So str new line. I just want to check if my EDX register is being affected in somehow, in some way. So 101, 178, and then 116, 35, 1, 2, 3, 4. So okay, it is not affected. So it's giving me a 1. So it is literally a 1. So now this 1, but I'm not fully understanding what's the real issue here because everything seems fine. Oh, it's been an hour. Damn. So I'm not fully understanding what's the issue now. So let me think. We calculate to add, sum up everything, and then let me see the formula again. So yeah, we add up everything, and then once everything has been summed up, we divide it by 4. After dividing it by 4, what's the answer? So let me quickly do the math. Let me see. So 101 times K0, which is 1, plus 178 times K1, which is 2, plus 116 times K2, which is 3, plus Y3, which is 35, times K3, which is 4, right? And then divided by 4. So divided by 4, if I divide it by 4, I'm getting the exact same answer, but then it's 0.25. So it's 945. That's the total. Then you divide it by 4. And then you get 236.25 on the calculator. So what is happening here? Because the remainder, mm, oh, so I see. So what's happening here? Let me see. If I say 944 divided by 4. Yeah. So the remainder is actually 1. So the way it calculates it is it's not actually converting to the right format, right? No matter how much you divide, it won't output it in the right format because 945 divided by 4, right? 4 goes there 236 times, and then the remainder is going to be 1. So it's literally a 1. So it is correct. It's just that we need to convert it and phrase it in the right way. So how would I phrase it in the right way? So in terms of, so I have to, so I feel like I sort of have to use the trick of percentages, right? Because if it's a 1, it's 25%. If it's a 2, it's 50%. If the remainder is 3, it's 35, it's 75%. And then if it's a 4, it's just going to be 100, right? It's just going to be 100%, which is 1, right? Which, yeah, but let's see. Mm, yeah, as you can see, it's in terms of like I said, it's in terms of percentages, like 25, 50, all those values, right? So let me try something. So let's think about what is 4, right? If you think about it, what is 4 in terms of percentage, right? If you take 100 divided by 4, what would you get? It's 25%, right? So basically, I will use that knowledge and multiply everything by 25. I think that should I think that should actually work. Let's test it out. So multiply, yeah, I'm gonna use that. So int x, I'm just gonna call it int x. I don't know what to call it. So basically, I'm using this. This is how this is how I'm calculating it. How would I get 4 in terms of percentages, right? So basically, divided by 100 is equals to 4. What would be x? X in this case would be 25. No, not the other way around. 100 divided by some x value. What would be x? It would be 25. Because I want to, that's the best way to go about converting this output into decimal form, into the right way. You have to sort of like use the percentages. So we have EAX and then we have EDX. I move the EDX value into there, and then here I'm just gonna multiply by int x, right? And then after multiplying, I can move back the answer into EDX, right? That value that I've multiplied, because remember at the bottom here, I'm outputting EDX. Or I can just, instead of outputting EDX, I just output X, right? I can also do that. So let me just choose the second approach. So let's test it out. Yeah, it's a pretty small thing. You don't have to stress about it, but let's calculate. So 101, 178, 116. Seems like it's the same. So yeah, it's the same. 35. The only thing that changes is the K. 1, 2, 3, 2. 1, 2, 3, 2. So it's 200 and wait, what am I doing? Did I do it the right way? Oh, well, did I do it the right way? Let me see. I moved the remainder, which is 3, right? Oh, I see my problem. Uh, Um, yeah, I see it's a huge problem. Let me tell you what the problem is. So you remember int x is 3, right? And here I'm outputting int x. I'm actually outputting 3. It's not the correct value. So I need to actually do this. Move the value of int x into, what is this? Into int x, the value that I'm going to get from multiplying, right? Remember, when you multiply, the answer is stored back into EAX. So the answer was still in EAX. I hadn't moved it into int x. That's where the problem was. So I need that answer. So I'm gonna do this 101, 178, 116, 35, 1, 2, 3, and a 2. There we go. There's the answer. And then for the other one, you can still, I feel like it's fine now. I don't have to test it, but then just to be sure, so that you can see that we're not cheating anything here. There we go, 236,25 is the answer. So try, if you, when you get the question right, try to represent it in this form, right? like in this form. So what I suggest is you just say 100 divided by x. What number would you need to substitute here, of which would give you 4 if you divide 100 by it? So I would have to use 25. So in this case, the value that I would multiply by is 25 to get the correct decimals, the correct decimal point. So that's it for today. Good luck with tomorrow's practical.